Hello there, and welcome to Whispers of Science, where the cosmos gets cozy and mysteries unfold like gentle bedtime stories. Tonight, we're embarking on a quiet journey into one of the universe's most profound puzzles, something that makes up most of everything, yet remains completely invisible: dark matter, the missing mass that holds galaxies together while slipping through our fingers like cosmic smoke. Before we drift into this celestial mystery, I'd love to know where in the world you're listening from and what draws you to the stars tonight. Perhaps you're settling in after a long day. Maybe you're curious about the invisible threads that weave through space, or you simply enjoy letting science lull you into peaceful contemplation. Whatever brought you here, I'm grateful you've joined me in this tranquil corner of the internet. If you find this gentle exploration soothing or intriguing, I'd be ever so thankful if you gave the video a like and perhaps subscribed it. Helps these whispered scientific stories reach others who might need a moment of wonder before sleep. And I do hope this isn't so fascinating that it keeps you wide awake, but if it does well, at least you'll drift off, knowing something extraordinary about the fabric of reality. So settle in, let your thoughts slow, and let's begin. Because somewhere in the vast darkness, between stars, between galaxies, between everything we can see, lies the story of what we cannot, the invisible scaffolding upon which our entire universe hangs. Imagine for a moment that you're looking at a bustling city at night. From high above, the lights twinkle like earthbound stars, revealing streets, buildings the pulse of human activity. But now imagine that for every glowing window you can see, there are five more buildings, completely dark, no lights, no visible signs of existence. Yet somehow the city's traffic flows around them. People navigate streets that curve around these invisible structures, the whole urban landscape shaped by things you simply cannot perceive. This is remarkably close to our situation. With the universe, we see stars and galaxies shining brilliantly against the cosmic dark. We map their positions, track their movements, measure their light. But all of this visible matter, everything that glows or reflects or emits radiation, accounts for less than 5% of what's actually out there. The remaining 95% exists in forms we cannot directly observe, cannot touch, cannot photograph. Yet their presence shapes everything we do see. Dark matter makes up roughly 27% of this cosmic inventory, and its story begins not with what we found, but with what we couldn't explain. It starts in the 1930s with an astronomer named Fritz Zwicky, who was studying something called the Coma Cluster, a collection of over 1,000 galaxies bound together by gravity. Zwicky noticed something peculiar. These galaxies were moving far too quickly. According to Newton's laws and our understanding of gravity, the galaxies in this cluster should have been moving much more slowly, given the amount of visible matter. He could observe it was as if someone had cranked up the cosmic speed limit, but only some objects got the memo. The galaxies were racing around as though held by much more mass than Zwicky could account for, much more than all the stars and gas he could see. Zwicky coined the term dark matter, or Dunkelmaterie in German, to describe this missing mass. But his observations were largely ignored or dismissed for decades. After all, it seemed impossible that the universe could be hiding most of itself in plain sight. Surely there was a simpler explanation. Perhaps Zwicky had miscalculated, Or maybe there were clouds of gas and dust blocking our view of additional stars. But the mystery persisted and deepened in the 1970s. Astronomer Vera Rubin began studying how stars orbit in spiral galaxies, like our own Milky Way, according to Kepler's laws, which govern planetary motion. Stars farther from a galaxy's center should orbit more slowly, just as planets farther from the Sun take longer to complete their orbits. But Rubin discovered something extraordinary. Stars at the edges of galaxies were moving just as fast as those closer to the center, sometimes even faster. It was as if the solar system's outer planets were racing around the Sun at the same speed as Mercury and Venus, which should be impossible unless there was far more mass in these galaxies than we could detect. Rubin's work provided compelling evidence that galaxies are embedded in vast halos of invisible matter extending far beyond their visible edges, like cosmic icebergs, with most of their bulk hidden beneath the surface. The evidence continued to mount. Gravitational lensing observations showed that massive invisible objects were bending light from distant galaxies. Computer simulations of cosmic evolution required enormous amounts of dark matter to reproduce the large scale structure we observe today. Galaxy collisions revealed that visible matter and dark matter could separate, with the dark matter passing through unaffected, while the visible matter crashed and heated up. Yet, despite decades of evidence and increasingly sophisticated detection attempts, dark matter remains stubbornly elusive. We know it's there because we can see its gravitational effects, but we cannot touch it, photograph it, or even directly interact with it in any way we've ever discovered. It's like having a conversation with someone you can hear, but never see their words affect you. Their presence changes the room, but they remain invisible. What exactly is this mysterious substance that outweighs all the stars and planets and black holes combined by more than 5 to 1? The honest answer is we don't know, and that ignorance represents one of the most humbling and exciting frontiers in modern science. We're like cosmic archaeologists trying to understand an ancient civilization by studying only the shadows they cast. The leading candidates for dark matter particles have wonderfully evocative names: weakly interacting massive particles, or WIMPs, sterile neutrinos, axions, primordial black holes. Each represents a different possibility for what this invisible mass might be. Some theories suggest dark matter consists of particles that interact only through gravity and the weak nuclear force, making them nearly impossible to detect. Others propose exotic particles that barely interact with ordinary matter at all. Laboratories deep underground are searching for these elusive particles using detectors so sensitive they must be shielded from cosmic rays and even natural radioactivity in the surrounding rock. Scientists cool these detectors to temperatures colder than outer space and wait, hoping that a dark matter particle might occasionally collide with an atomic nucleus, creating a tiny flash of light or heat that could be measured. Meanwhile, particle accelerators, like the Large Hadron Collider, are trying to create dark matter particles by smashing protons together at enormous energies. The idea is that these high energy collisions might produce dark matter particles that would immediately escape detection, leaving behind only the signature of missing energy and momentum, like footprints in snow that reveal the passage of an invisible walker. Space based telescopes are mapping the distribution of dark matter by observing how its gravity affects the light from distant galaxies. They're creating three-dimensional maps of this invisible scaffolding, showing how dark matter forms a cosmic web of filaments and nodes, with galaxies lighting up like Christmas ornaments strung along these dark threads. But perhaps the most profound implication of dark matter is what it tells us about our place in the universe. We humans are made of ordinary matter: protons, neutrons, electrons, the same stuff that makes up stars and planets and interstellar dust. Yet this ordinary matter represents less than 5% of everything that exists. We are not just small in the universe, we are made of the universe's rarest ingredient. This realization is both humbling and oddly comforting. We are part of something vast and mysterious, connected to cosmic processes we barely understand, yet our curiosity, our ability to detect and study dark matter, even without being able to touch it, represents something remarkable. The universe has evolved conscious observers capable of discovering their own cosmic insignificance and finding wonder in it. Dark matter also raises profound questions about the nature of reality itself. If most of the universe consists of things we cannot directly perceive, what does that say about the limits of human knowledge? Are there entire realms of existence that will forever remain beyond our reach, or will future generations develop new senses, new instruments, new ways of interacting with the cosmos that make today's dark matter as visible as the stars? Some scientists wonder whether dark matter might even support its own complex structures. Could there be dark matter planets, dark matter life forms, entire civilizations existing alongside our own, but in a parallel realm of matter that barely touches ours? It sounds like science fiction, but the universe has already surprised us by hiding most of itself. Perhaps it has more surprises in store. The search for dark matter has also led to unexpected discoveries and technological advances. The sensitive detectors developed for dark matter research have found applications in medical imaging and national security. The computational techniques used to simulate dark matter's effects have improved weather forecasting and climate modeling. The quest to understand the invisible has illuminated the visible in ways we never anticipated. But beyond practical applications, dark matter represents something more fundamental about the scientific endeavor. It reminds us that the universe is under no obligation to be easily understood, that nature's deepest secrets often hide in plain sight, and that some of the most important discoveries begin with the simple observation that things don't quite add up the way we expect them to. Fritz Zwicky's galaxies were moving too fast. Vera Rubin's stars were orbiting too quickly. These small discrepancies between observation and expectation opened doorways to cosmic mysteries that continue to unfold today. They remind us that science advances not just through grand theories and elaborate experiments, but through careful attention to the details that don't quite fit. As we drift deeper into this exploration of the universe's missing mass, we'll discover how dark matter shapes the cosmic web, how it influences the formation of galaxies and stars, and how it might ultimately determine the fate of everything. We know we'll explore the ingenious methods scientists use to study something that refuses to be seen, and the profound questions that arise when most of reality remains hidden from view. So let your mind wander into this invisible realm where gravity writes stories in languages we're still learning to read, where the absence of light reveals the presence of something far more mysterious than darkness itself. Because in the space between what we know and what we can see lies one of the universe's most elegant and enduring puzzles, waiting patiently for us to solve it. The story of dark matter is ultimately a story about invisible architecture, about the hidden framework that gives shape to everything we see. Imagine trying to understand a magnificent cathedral by examining only the stained glass windows. The sunlight streaming through them reveals colors and patterns of breathtaking beauty. But without seeing the stone arches, the flying buttresses, the massive pillars that support it all, you'd never understand how such beauty could stand against time and gravity. This is our predicament with the cosmos we see, the luminous windows, the glowing galaxies scattered across space like jewels on black velvet. But the supporting structure, the cosmic buttresses that hold it all together, remain frustratingly invisible. Yet their presence whispers through every observation, every measurement, every attempt to map the universe's grand design. Let's begin with the cosmic web itself. If you could somehow step outside our universe and look down upon it from an impossible vantage point, you'd see something that resembles a vast three-dimensional spider web stretching across billions of light years. Thin filaments of matter connect dense nodes where galaxies cluster like dewdrops caught on silk threads. Between these filaments lie enormous voids, cosmic bubbles of near emptiness that dwarf entire galaxy clusters. But here's the remarkable thing. Most of this web is invisible. The filaments we can trace through the distribution of galaxies represent only the tip of an iceberg. The luminous matter follows dark matter's lead like iron filings, revealing the shape of a magnetic field. We cannot see. The dark matter got there first, laying down the pathways that ordinary matter would later follow like cosmic breadcrumbs, leading to the formation of everything we observe. This invisible scaffolding began its work very early in the universe's history, just a few 100,000 years after the Big Bang, when the cosmos was still a hot, dense soup of particles. As the universe expanded and cooled, ordinary matter was still too energetic, too chaotic to clump together effectively. It was like trying to build sand castles while waves crash over the beach. But dark matter was different. It didn't interact with the fierce radiation that kept ordinary matter stirred up like cosmic soup. Dark matter particles could already begin gathering under their own gravity, forming the first structures, the first seeds around which everything else would eventually coalesce when the universe finally cooled enough for ordinary matter to settle down. It found these dark matter scaffolds already waiting patient, invisible foundations upon which to build the first stars and galaxies. Without dark matter, the universe would be a very different place. Computer simulations show us what might have happened. Ordinary matter, left to its own devices, would have formed only small diffuse structures, nothing like the magnificent spiral galaxies and towering galaxy clusters. We observe there would be no Milky Way, no Andromeda, no cosmic cities of billions of stars, just a thin gruel of gas scattered across an expanding void. The gravitational embrace of dark matter halos allowed ordinary matter to fall inward to concentrate and eventually reach the densities needed for star formation. It's as if dark matter provides the gravitational glue that holds the universe's architecture together. Without it, the cosmic construction project would have failed before it began. But dark matter's influence extends beyond just providing scaffolding. It actively shapes how galaxies form and evolve. The dark matter halo surrounding our own Milky Way extends far beyond the visible disk of stars, perhaps 10 times farther. This invisible envelope helps determine how fast stars orbit, how the galaxy responds to gravitational encounters with neighbors, and how it will evolve over cosmic time. When galaxies collide and merge, events that happen regularly throughout cosmic history, dark matter plays a crucial role because dark matter particles don't collide with each other the way ordinary matter does. They can pass right through during galactic encounters, while the visible matter crashes together, heats up, and sometimes gets flung away entirely. The dark matter halos merge more smoothly, providing gravitational stability that helps the resulting galaxy maintain its structure. One of the most dramatic examples of this occurred in a galaxy cluster called the Bullet Cluster. Here, two galaxy clusters collided at enormous speeds, creating what astronomers describe as a cosmic crash test. The ordinary matter, in the form of hot gas, crashed together and was slowed by the collision glowing brightly in X ray light. But the dark matter passed right through. Largely unaffected gravitational lensing maps show that most of the mass in this system is now separated from the visible matter, providing some of the clearest evidence that dark matter really is something different from ordinary matter. This ghostly behavior of dark matter passing through itself and through ordinary matter almost without interaction has led scientists to describe it as collisionless. It's like having a universe populated by cosmic phantoms that can overlap and interpenetrate without ever touching each other. Yet their gravitational influence shapes everything around them. The search for dark matter has become one of the most intensive scientific endeavors of our time. Laboratories buried deep underground shield their delicate detectors from cosmic rays that constantly bombard Earth's surface. Scientists wait in these subterranean cathedrals of science, hoping to catch the whisper of a dark matter particle as it passes through their apparatus. The idea is elegantly simple. If dark matter particles are streaming through space, they should occasionally collide with atomic nuclei in these detectors. The collision would deposit a tiny amount of energy, perhaps causing a crystal to vibrate or a noble gas to emit a brief flash of light. But detecting such events requires extraordinary sensitivity, like trying to hear a pin drop during a thunderstorm. Some detectors use tanks of liquid xenon cooled to temperatures that would freeze the air in your lungs. Solid others employ silicon crystals, so pure they make the finest diamonds look contaminated. All are designed to catch the faintest possible signal from the invisible realm that surrounds us. Yet, despite decades of searching and increasingly sensitive instruments, dark matter continues to elude direct detection. Meanwhile, high energy particle accelerators are taking a different approach. Instead of waiting for dark matter to come to them, they're trying to create it by smashing protons together at energies that recreate conditions not seen since the first moments after the Big Bang. The hope is that these collisions might produce dark matter particles that would immediately escape the detector, leaving behind only indirect evidence of their creation. It's like trying to study an invisible person by throwing baseballs at them and watching which ones mysteriously change direction. The dark matter particles themselves would vanish into the cosmic background, but their creation would show up as missing energy in the collision, a gap in the accounting that could only be explained by something unseen carrying away momentum and energy. Space based telescopes are mapping dark matter's distribution using gravitational lensing, the way massive objects bend light, like cosmic magnifying glasses, by carefully measuring how the light from distant galaxies is distorted. Astronomers can create maps of where dark matter concentrates. Even though they cannot see it directly, these maps reveal dark matter's role in the cosmic web, showing how it connects galaxy clusters across vast distances and creates the invisible highways along which ordinary matter flows. But perhaps the most intriguing aspect of dark matter research is how it forces us to confront the limits of human perception. We are creatures evolved to navigate a world of solid objects, reflected light, familiar forces. Yet most of the universe operates according to rules and contains substances completely outside our sensory experience. Dark matter doesn't emit light, doesn't absorb light, doesn't reflect light. It interacts with the electromagnetic force that governs chemistry and biology so weakly that it might as well not interact at all from dark matter's perspective. We ordinary matter beings might be the ghosts, insubstantial wisps of interacting particles in a universe dominated by something far more substantial yet invisible. This perspective shift has profound implications for how we understand our place in the cosmos. We often think of empty space as truly empty, but if dark matter pervades the universe, then space is actually full of invisible substance right now. As you listen to these words, countless dark matter particles are streaming through your body, through the earth, through everything around you, at speeds of hundreds of kilometers per second. They pass through you as if you weren't there, because to them you essentially aren't the electromagnetic forces that hold your atoms together, that create the sensation of solidity, are irrelevant to dark matter. It inhabits the same space we do, but experiences a completely different version of reality one, where our entire material world is as insubstantial as shadows. Some scientists have wondered whether dark matter might support its own complex structures. Could there be dark matter, planets orbiting dark matter? Stars could dark matter have evolved its own forms of complexity, perhaps even life forms that exist alongside us, but in a parallel realm we can barely detect it. Sounds fantastical, but the universe has already surprised us by hiding most of itself. Why not hide entire civilizations as well? The implications extend beyond physics into philosophy and our understanding of knowledge itself. If most of reality consists of things we cannot directly perceive, what does that say about the nature of truth, about the reliability of our senses, about the completeness of any worldview based solely on direct experience? Dark matter reminds us that absence of evidence is not evidence of absence, that the universe is under no obligation to reveal itself easily to creatures like us who evolved to see reflected sunlight and feel electromagnetic forces. The cosmos contains mysteries that require not just better instruments, but entirely new ways of thinking about what it means to know something. Yet there is something beautiful about this cosmic humility, the recognition that we are surrounded by mystery, that most of reality remains hidden from our direct experience, opens up possibilities rather than closing them down. It suggests that the universe still holds wonders. We cannot yet imagine discoveries that will reshape our understanding of everything. The search for dark matter has already transformed our view of the cosmos from a universe made primarily of stars and gas to one dominated by invisible substance. It has revolutionized our understanding of how galaxies form, how structure emerged from primordial smoothness, how the cosmic web took shape, and it has forced us to develop new mathematical tools, new detection methods, new ways of mapping the unseeable. But perhaps most importantly, dark matter has taught us to pay attention to discrepancies, to the small ways observations don't quite match expectations. Fritz Zwicky's fast moving galaxies, Vera Rubin's unexpectedly rapid stellar orbits. These were tiny anomalies that opened doorways to cosmic revelations. They remind us that science advances through careful observation, through noticing when things don't quite add up, through having the courage to propose that most of the universe might be hiding in plain sight. As we continue our gentle exploration of this invisible realm, we'll discover how dark matter might determine the ultimate fate of everything, how it connects to other cosmic mysteries, and how the search for it pushes the boundaries of human knowledge. We'll explore the possibility that dark matter might not be particles at all, but something even stranger, and we'll consider what it means to live in a universe where most of reality remains beautifully hidden from view. So let us drift deeper into this cosmic mystery where absence reveals presence, where the invisible shapes the visible, and where the greatest discoveries often begin with the simple recognition that something doesn't quite make sense, because in the gentle tension between what we observe and what we expect lies the quiet promise of understanding truths about our universe that are stranger and more wonderful than anything we might have imagined. The quest to understand dark matter has led us down some of the most curious pathways in the history of science, where physicists find themselves playing cosmic detectives armed with the strangest clues imaginable. Picture trying to solve a mystery where you can never see the culprit, never find fingerprints, never catch them in the act, yet their influence is written across every crime scene in the universe. One of the most ingenious approaches involves something called direct detection, where scientists essentially turn the entire Earth into a shield. Deep beneath mountains, in abandoned mines, and purpose built caverns, researchers have constructed some of the most sensitive instruments ever devised. These underground cathedrals of science exist in a world of perpetual darkness, where even the faintest whisper of cosmic radiation is filtered out by miles of solid rock above. In these subterranean laboratories, tanks of liquid xenon sit colder than the space between stars, waiting with infinite patience for the rarest of events. The xenon atoms are arranged in perfect crystalline arrays, each one a potential target for a dark matter particle that might, just might, collide with it. When such a collision occurs, if it occurs, it would release energy equivalent to dropping a grain of sand from the height of your fingertip. Detecting such a minuscule event requires instruments so sensitive they can measure temperature changes smaller than a billionth of a degree. The scientists who tend these detectors speak in whispers about background noise, about false signals that could masquerade as the real thing. They worry about cosmic rays that slip through their rocky shields, about natural radioactivity in the detector materials themselves, about vibrations from passing trucks miles away. It's like trying to hear a butterfly's footsteps during an earthquake, except the butterfly might not exist and the earthquake never stops. Yet, despite years of vigilant waiting, despite detectors that grow more sensitive with each passing season, dark matter continues its ghostly passage through our world without leaving so much as a trace. The silence is profound and puzzling. Either dark matter interacts even more weakly with ordinary matter than we imagined, or it's something entirely different from what we expected. This has led some researchers to explore indirect detection methods, looking not for dark matter itself, but for the products of its destruction. The theory suggests that when dark matter particles collide with each other, they might annihilate and produce ordinary particles that we can detect. It's like studying fireworks by watching the sparks they throw off, even when the fireworks themselves are invisible. Space based telescopes scan the cosmos for unexpected gamma rays or other high energy particles that might signal dark matter annihilation in the dense cores of galaxies or in the dark matter halos that surround them. Also, they search for signatures in the cosmic background radiation for subtle patterns that might reveal dark matter's influence on the universe's earliest light. Meanwhile, particle accelerators take the opposite approach entirely. Instead of waiting for dark matter to reveal itself, they attempt to create it from scratch by smashing protons together at the energies that briefly recreate conditions from the first moments after the Big Bang. Scientists hope to produce dark matter particles in controlled laboratory conditions. The challenge is that any dark matter particles created would immediately escape, invisible and undetectable by the instruments surrounding the collision point. But their escape would leave evidence, like a missing person whose absence proves they were there. Scientists look for missing energy, for momentum that doesn't balance, for the telltale signs that something was created and then vanished into the cosmic background. These experiments have produced some of the most precise measurements in the history of science, yet they too have found only absence where they hoped to find presence. Each negative result narrows the possibilities, ruling out certain types of dark matter particles while pointing toward others that remain tantalizingly beyond reach. The more we search for dark matter, the stranger it becomes. Some theories suggest it might consist of particles so massive they make protons look like dust motes, while others propose particles so light they barely qualify as matter at all. Some models invoke entire hidden sectors of physics, parallel universes of dark particles that mirror our own world but interact with it only through gravity. There are proposals for dark photons that carry dark electromagnetic forces, dark atoms that form dark chemistry, even dark planets and dark stars that shine with dark light we cannot see. These aren't flights of fancy, but serious scientific proposals backed by mathematical models and observational constraints. The universe has already surprised us by hiding most of itself. Perhaps it has hidden entire realms of complexity as well. One particularly intriguing possibility is that dark matter might not be particles at all, but something far stranger. Some physicists have proposed that what we interpret as dark matter might actually be evidence that our understanding of gravity itself is incomplete. Perhaps the force that holds galaxies together operates differently on cosmic scales than it does in our solar system. These modified gravity theories suggest that space and time themselves might behave in unexpected ways when dealing with the vast distances and enormous masses of galaxy clusters. It's a radical idea that would require rewriting fundamental physics, but it's not without precedent. Einstein's general relativity completely transformed our understanding of gravity, revealing that what Newton thought was a force was actually the curvature of space-time itself. But modified gravity faces its own challenges. The cosmic microwave background radiation, the afterglow of the Big Bang, shows patterns that seem to require dark matter to explain. Galaxy collisions, like the bullet cluster, appear to separate ordinary matter from gravitational effects in ways that suggest dark matter really is a distinct substance. The evidence continues to point toward invisible particles rather than modified physics. Perhaps the most humbling aspect of the dark matter mystery is how it reveals the limitations of human intuition. We evolved in a world where seeing meant understanding, where touching confirmed reality, where the fundamental forces of nature revealed themselves through direct experience. But dark matter operates in a realm completely removed from human sensory experience. It's as if we discovered that most of the world's population consists of people who cannot see us, cannot hear us, cannot feel our touch, yet whose presence shapes every aspect of our lives. They build cities we cannot perceive, create art we cannot appreciate, live entire lives in parallel to our own while remaining forever beyond our ability to interact with them directly. This parallel existence extends to the very ground beneath our feet. As you sit reading these words, dark matter particles are streaming through your body at hundreds of kilometers per second. They pass through the earth as if it were empty space, through buildings and mountains and oceans without slowing down or changing direction. We exist in a universe that is simultaneously full and empty, solid and transparent, depending entirely on which type of matter you happen to be made of. The implications stretch beyond physics into philosophy and consciousness studies. If most of reality consists of things we cannot directly perceive, what does that say about the nature of knowledge itself? How many other hidden layers might the universe contain? Are there forms of existence so foreign to our experience that we lack even the concepts to imagine them? Some researchers have begun to wonder whether consciousness itself might be related to these hidden aspects of reality, not in any mystical sense, but in the recognition that consciousness allows certain arrangements of matter to become aware of their own existence and to contemplate the nature of the universe they inhabit. Perhaps the universe's capacity to know itself through conscious observers is as fundamental as the dark matter that shapes its structure. The search for dark matter has also revealed unexpected connections between the smallest and largest scales of existence. The same quantum mechanical principles that govern the behavior of individual atoms also influence how dark matter might interact with ordinary matter. The same gravitational forces that hold galaxies together operate in the detectors buried deep underground. This unity of physics across cosmic scales suggests that understanding dark matter might unlock insights into other mysteries as well. The hierarchy problem in particle physics, the nature of quantum gravity, the ultimate fate of the universe. All these questions might be connected to the invisible substance that surrounds us. As technology advances, new approaches to dark matter detection continue to emerge. Quantum sensors that exploit the strange properties of entangled particles might be sensitive enough to detect dark matter interactions that have eluded conventional detectors. Gravitational wave observatories might glimpse the collision of dark matter structures too massive and distant for any other instrument to perceive. Space based missions are being planned that would map dark matter's distribution with unprecedented precision, creating three-dimensional charts of the invisible scaffolding that supports our universe. These cosmic cartographers work to reveal the hidden geography of space itself, showing how dark matter flows like invisible rivers between galaxy clusters and pools and vast reservoirs around individual galaxies. But perhaps the most intriguing possibility is that dark matter might reveal itself through effects we haven't yet thought to look for. The history of science is filled with discoveries that came from unexpected directions, phenomena that revealed themselves only when researchers stopped looking for what they expected and started paying attention to what was actually there. The gentle whisper of dark matter might be all around us, speaking in languages we haven't yet learned to understand. Its influence might be written in the subtle wobbles of distant stars, in the patterns of cosmic ray particles, in the quantum fluctuations of empty space itself. We are surrounded by clues we cannot yet interpret, evidence we cannot yet recognize, speaking to us in the soft voice of a universe that guards its deepest secrets carefully. As we continue our drift through this cosmic mystery, we approach questions that touch the very foundations of reality itself. What does it mean for something to exist if it cannot be directly observed? How do we study a phenomenon that reveals itself only through its absence? And what profound truths about the nature of existence might be hidden in the space between what we can see and what we know must be there? The universe has spent billions of years weaving dark matter into its very fabric, creating a cosmos where the invisible outweighs the visible by more than 5 to 1. In learning to perceive this hidden reality, we are developing new ways of seeing, new methods of knowing, new relationships with the mystery that surrounds us. And in that patient search for understanding, we discover not just the nature of dark matter, but something profound about the nature of curiosity itself. The story of dark matter becomes even more intriguing when we consider how it might shape the ultimate destiny of our universe. Like a gentle conductor orchestrating a cosmic symphony that will play out over trillions of years, dark matter's gravitational influence may determine whether our cosmos ends in fire, ice, or something altogether more mysterious. Picture the universe as a vast ocean where dark matter creates the currents, the tides, the deep flowing movements that carry everything along. Galaxies ride these invisible streams like ships on cosmic waters, their paths determined by forces they cannot see but cannot escape. And just as ocean currents shape climate and weather patterns across our planet, dark matter's distribution influences the grand patterns of cosmic evolution. In the early universe, when everything was much closer together, dark matter helped ordinary matter clump into the first stars and galaxies. But as space continues to expand, as distances between galaxy clusters grow ever larger, dark matter's role is changing. The same gravitational glue that once brought things together now struggles against the relentless expansion of space itself. This cosmic tug of war between dark matter's attractive gravity and space's expansion creates one of the most poignant stories in all of science. Imagine two dancers slowly being pulled apart by forces beyond their control, their gravitational embrace growing weaker with each passing moment. Eventually, the expansion wins, and structures that took billions of years to form begin their long, lonely drift into isolation. But dark matter doesn't give up easily. Computer simulations show us glimpses of the far future, billions of years from now, when most stars will have burned out and galaxies will be islands of darkness in an ever expanding sea. Even then, dark matter halos will persist, invisible lighthouses marking where galaxies once shone brightly. These ghostly remnants will continue their patient gravitational dance long after the last star has flickered and died. The interplay between dark matter and something called dark energy adds another layer to this cosmic tale. If dark matter is the universe's hidden architecture, then dark energy is its invisible engine, driving the acceleration of cosmic expansion. Together, these two dark components make up roughly 95% of everything, leaving ordinary matter as a kind of cosmic afterthought, beautiful but ultimately peripheral to the universe's grand design. Some theories suggest that dark matter and dark energy might be connected, two faces of a single phenomenon we don't yet understand. Perhaps the same fields that create dark matter also drive cosmic acceleration, linking the universe's smallest and largest scales in ways that would revolutionize our understanding of reality itself. It's like discovering that the foundation of a building and the wind that moves through it are somehow the same thing, expressed in different ways. The search for these connections has led scientists to propose some wonderfully exotic possibilities. Maybe dark matter consists of particles that exist in extra dimensions, occasionally flickering into our three-dimensional reality, like shadows cast by objects in a higher dimensional space. Perhaps it's made of particles that travel backward through time, or exist in a state of quantum superposition that allows them to be in multiple places simultaneously. One particularly elegant theory suggests that dark matter might be its own antiparticle, meaning that when two dark matter particles meet, they annihilate each other completely, releasing energy that could potentially be detected. This would make dark matter a kind of cosmic Ouroboros, a substance that consumes itself while somehow maintaining its presence throughout the universe. The mathematics of these theories often reads like poetry, written in the language of quantum fields and curved spacetime. Equations describe particles that dance through dimensions we cannot perceive, forces that operate according to symmetries beautiful enough to bring tears to a physicist's eyes. Even if we never directly detect dark matter, the theoretical frameworks developed to understand it have expanded human knowledge in profound and unexpected ways. Consider how the search for dark matter has transformed our relationship with emptiness itself. What we once thought of as empty space, the vacuum between stars and galaxies, is now understood to be a bustling metropolis of virtual particles, quantum fluctuations, and invisible matter streams. The void is not void at all, but filled with activity we're only beginning to comprehend. This shift in perspective extends to our understanding of what it means to be solid, to be real, to exist in any meaningful sense. The atoms in your body, the chair you're sitting on, the ground beneath your feet, all of this is held together by electromagnetic forces that represent a tiny fraction of the universe's total influence. We are like beings made of foam, floating in an ocean of substance we cannot feel but cannot escape. Yet there is something profound about our ability to detect dark matter's presence despite never being able to touch it. Through gravitational lensing, through the motion of galaxies, through the subtle patterns in the cosmic microwave background, we have learned to see the unseeable. We have developed new senses, extended our perception beyond the narrow band of electromagnetic radiation our eyes evolved to detect. This represents a kind of cosmic empathy, an ability to understand and map a form of existence completely unlike our own. We have learned to think like dark matter, to predict where it flows and pools, to understand its behavior despite never directly experiencing its presence. It's as if we've learned to navigate by feeling the gravitational equivalent of wind patterns, sensing the topology of invisible landscapes through their effects on visible matter. The implications ripple outward into questions about life itself. If most of the universe consists of dark matter, could life based on dark matter exist? Could there be dark matter ecosystems, dark matter evolution, dark matter consciousness developing along pathways completely parallel to our own? The universe might be teeming with forms of life and intelligence that remain forever beyond our ability to communicate with them. This possibility is both humbling and oddly comforting. It suggests that life and consciousness might be far more common in the universe than we imagine, just not in forms we would recognize. The cosmos might be filled with thinking beings contemplating their own existence, developing their own science, asking their own questions about the nature of reality, all while remaining as invisible to us as we are to them. Some researchers have begun to explore whether dark matter might even influence biological processes on Earth. Could the streams of dark matter flowing through our galaxy affect evolution, climate, or the development of life itself? These questions venture into speculative territory, but they remind us that we exist embedded in cosmic processes far larger and stranger than anything in our direct experience. The seasonal variation in Earth's motion through the galaxy creates subtle changes in the flux of dark matter particles passing through our planet. Some scientists have wondered whether these cosmic seasons, lasting tens of millions of years, might correlate with mass extinction events or periods of rapid evolutionary change. It's a long shot, but it illustrates how dark matter connects the smallest scales of existence to the largest. As we drift deeper into this exploration, we encounter questions that challenge our most basic assumptions about reality. If something can exist, can influence the structure of galaxies, can determine the fate of the universe, yet remain completely undetectable through direct interaction, what does that say about the nature of existence itself? Perhaps the most beautiful aspect of the dark matter mystery is how it forces us to expand our definition of what it means to know something. We cannot see dark matter, cannot touch it, cannot photograph it, yet we know it's there with greater certainty than we know many things we interact with daily. This knowledge comes not from direct sensation, but from careful reasoning, from following logical threads through mathematical landscapes, from trusting in the consistency of natural laws, even when they lead us to uncomfortable conclusions. This kind of knowing requires a different relationship with uncertainty, a comfort with mystery that allows for wonder without demanding immediate answers. It asks us to hold space for possibilities we cannot yet imagine, to remain curious about questions we may never be able to fully resolve. In a world that often demands quick answers and simple explanations, dark matter teaches us the value of patient contemplation. The search for dark matter has also revealed something profound about the collaborative nature of human knowledge. No single experiment, no individual scientist, no particular observation could have revealed the existence of this invisible realm. It took decades of careful work by thousands of researchers, each contributing pieces to a puzzle none of them could see in its entirety. This distributed discovery process mirrors dark matter itself, invisible threads connecting individual efforts into a larger structure of understanding. Like the cosmic web that dark matter creates throughout the universe, scientific knowledge forms through countless small connections, building scaffolding strong enough to support insights that transform our view of reality. As we prepare to drift toward the conclusion of our gentle exploration, we find ourselves changed by the encounter with cosmic mystery. Dark matter has taught us to see with new eyes, to perceive patterns in absence, to find meaning in emptiness. It has shown us that the universe is far stranger and more wonderful than we ever imagined, filled with forms of existence that challenge every assumption about what it means to be real. The whispers of science that brought us here continue to echo through the cosmic dark, carrying questions that may outlive our civilization, mysteries that may persist long after the last star has burned out. And in those whispers, we hear something profound about the relationship between consciousness and cosmos, between the observer and the observed, between the known and the unknowable that surrounds us like a gentle, invisible embrace. In the quiet spaces between galaxies, where even starlight becomes a distant memory, dark matter continues its ancient work with the patience of geological time. Here, in regions so vast that light takes millions of years to cross them, the invisible scaffolding of the universe reveals its most delicate architecture. These cosmic voids, once thought to be empty, are now understood to be threaded with dark matter filaments so thin they make spider silk look substantial by comparison. It's in these seemingly barren regions that some of the most elegant experiments in dark matter detection are taking place. Scientists have learned to use the entire cosmos as their laboratory, turning distant quasars into cosmic flashlights and galaxy clusters into gravitational telescopes. They watch how light bends around invisible masses, how the fabric of space-time dimples under the weight of things that cannot be seen, how the universe's own geometry betrays the presence of its hidden contents. One particularly ingenious approach involves studying the cosmic microwave background radiation, that faint afterglow of the Big Bang that still permeates every corner of space. This ancient light carries within its subtle temperature variations the fingerprints of dark matter's influence from when the universe was only a few 100,000 years old. By analyzing these patterns with exquisite precision, scientists can reconstruct how dark matter was distributed in the infant cosmos and trace its evolution across billions of years. The pictures that emerge from this analysis are breathtaking in their scope. We see dark matter flowing like invisible rivers between galaxy clusters, pooling in vast reservoirs around individual galaxies, creating a cosmic web of stunning complexity and beauty. These maps of the unseeable represent one of humanity's greatest intellectual achievements, revealing the hidden geography of existence itself through pure mathematical reasoning and careful observation. But perhaps the most profound aspect of dark matter research is how it changes our relationship with the concept of evidence itself. In our daily lives, we trust what we can see, touch, measure directly. Yet here is something that outweighs all the stars in the sky, something that shapes the very structure of reality, yet remains as intangible as a whispered secret. We know it exists not because we can point to it and say there, but because its absence would make the universe incomprehensible. This represents a new kind of faith, not religious, but scientific, a trust in the consistency of natural laws, even when they lead us to conclusions that strain our everyday understanding. It's the faith of astronomers who see galaxies spinning too fast and conclude that invisible matter must be holding them together, the faith of cosmologists who observe the universe's expansion history and deduce the presence of substances that have never been directly detected. The search for dark matter has also opened unexpected windows into the nature of time itself. Because light travels at a finite speed, when we observe distant galaxies, we see them as they were millions or billions of years ago. By studying how dark matter's distribution has changed over cosmic time, we can watch the universe's invisible architecture evolve in slow motion, witnessing the gradual construction of the cosmic web across eons of geological time. These observations reveal dark matter to be remarkably stable, changing its distribution slowly and predictably according to the laws of gravity. While ordinary matter undergoes dramatic transformations, forming stars that burn brightly and die explosively, dark matter maintains its patient presence, providing the gravitational foundation upon which all these cosmic dramas play out. It's like discovering that beneath all the surface activity of a bustling city lies a geological foundation that changes only imperceptibly over human timescales. The stability of dark matter raises intriguing questions about information and memory in the universe. If dark matter particles rarely, if ever, interact with each other or with ordinary matter, they might preserve information about the early universe with extraordinary fidelity. Each dark matter particle could be carrying within its motion and position a record of cosmic conditions from billions of years ago, making the invisible realm around us a kind of cosmic archive waiting to be read. Some researchers have begun to explore whether this archived information might be accessible through careful study of dark matter's current distribution. By working backward from present day observations, they hope to reconstruct the initial conditions that gave birth to cosmic structure, essentially reading the universe's own memory of its youth, written in the language of gravitational dynamics. This possibility transforms our understanding of what it means to study history. Archaeological records on Earth extend back only a few thousand years, geological records a few billion. But dark matter potentially preserves information from the very first moments after the Big Bang, when the universe was smaller than an atomic nucleus and hotter than the core of any star. In learning to read this cosmic memory, we might discover truths about existence itself that have been hidden for nearly 14 billion years. The technological challenges of dark matter detection have pushed human ingenuity to remarkable extremes. The underground laboratories where scientists search for these elusive particles represent some of the most sophisticated engineering projects ever undertaken. They must isolate their detectors not only from cosmic rays and natural radioactivity, but from vibrations so subtle they could be caused by ocean waves breaking on shores hundreds of miles away. The materials used in these detectors are purified to levels that would make pharmaceutical companies envious. Every component must be screened for trace amounts of naturally occurring radioactive elements that could masquerade as dark matter signals. Some detectors use copper that was mined before nuclear weapons testing began, because even the tiny amounts of artificial radioactivity introduced into the environment by atomic bombs could interfere with the measurements. These extreme measures create environments that are among the quietest places on Earth, not just acoustically, but in terms of any kind of particle interaction. In these subterranean cathedrals of science, researchers wait with instruments so sensitive they could detect the energy released by a single bacterium swimming across a petri dish. Yet, even this extraordinary sensitivity may not be enough to catch dark matter's whispered passage through our world. The possibility that dark matter might forever elude direct detection has led some scientists to embrace what they call the indirect approach. Instead of trying to catch dark matter particles themselves, they search for the products of dark matter interactions, the cosmic equivalent of studying a dancer by watching their shadow on the wall. This approach has opened up entirely new fields of astronomy, from gamma ray telescopy to neutrino detection, each offering a different window into the invisible realm. Space based observatories now scan the cosmos for unexpected sources of high energy radiation that might signal dark matter annihilation in the dense cores of galaxies. They look for patterns in the cosmic ray particles that constantly bombard Earth's atmosphere, searching for signatures that might indicate dark matter decay or interaction in distant regions of space. Each observation adds another piece to the puzzle, another constraint on what dark matter might be and how it might behave. But even as technology advances and our observational capabilities expand, dark matter maintains its essential mystery. It's as if the universe has constructed the perfect hiding place, a form of matter that interacts just strongly enough through gravity to make its presence known, but weakly enough through other forces to remain forever beyond direct grasp. This tantalizing near accessibility has driven some researchers to describe dark matter as the universe's greatest tease, always present but never quite within reach. The psychological impact of studying something so thoroughly elusive cannot be underestimated. Generations of scientists have devoted their careers to understanding dark matter, developing increasingly sophisticated theories and building ever more sensitive detectors. Yet the substance itself remains as mysterious as when Fritz Zwicky first noticed those fast moving galaxies nearly a century ago. This requires a particular kind of intellectual courage, the willingness to pursue knowledge even when the goal might remain perpetually on the horizon. Yet there's something deeply satisfying about this cosmic game of hide and seek. Each negative result, each failed detection, each theoretical prediction that doesn't quite match observation teaches us something new about the nature of reality. We learn not just what dark matter is, but what it isn't, gradually narrowing the possibilities and refining our understanding of what kinds of physics might govern the invisible realm. The search has also revealed unexpected connections between seemingly unrelated areas of science. Particle physics and cosmology, once separate disciplines, have become intimately connected through dark matter research. The same quantum mechanical principles that govern the behavior of individual atoms also influence how dark matter might interact with ordinary matter. The same gravitational forces that hold galaxies together operate in the detectors buried deep underground. This unity of physics across vastly different scales suggests that understanding dark matter might unlock insights into other fundamental mysteries. The hierarchy problem in particle physics, the nature of quantum gravity, the ultimate fate of the universe, all these questions might be connected to the invisible substance that surrounds us. Solving the dark matter puzzle could trigger a cascade of discoveries that transform our understanding of existence itself. As our exploration draws toward its gentle conclusion, we find ourselves standing at the edge of one of the greatest mysteries in human knowledge. Dark matter represents more than just missing mass or invisible particles. It embodies our relationship with the unknown, our capacity to perceive truth through reasoning rather than direct sensation, our ability to remain curious about questions we may never fully resolve. In the end, perhaps the most remarkable thing about dark matter is not what it is, but what it reveals about who we are. Here we stand, beings made of the universe's rarest ingredient, equipped with consciousness and curiosity, sufficient to detect the presence of substances we cannot touch, to map the distribution of matter we cannot see, to contemplate the implications of discoveries we cannot fully comprehend. The universe has spent nearly 14 billion years weaving dark matter into its very fabric, creating a cosmos where the invisible outweighs the visible, where mystery outweighs certainty, where wonder remains the most appropriate response to existence itself. And in our patient search for understanding, in our willingness to follow evidence wherever it leads, even into realms beyond direct experience, we discover not just the nature of dark matter, but something profound about the nature of knowledge itself. The whispers of science that brought us here continue to echo through the cosmic dark, carrying questions that may outlive our species, mysteries that may persist long after the last star has burned out. And in those whispers, we hear something timeless about the relationship between mind and cosmos, between the observer and the observed, between the known and the unknowable that embraces us like the gentle, invisible presence of dark matter itself, always there, always influential, forever just beyond our grasp, yet somehow, mysteriously, within our understanding. The gentle persistence of dark matter extends even into our most intimate moments of contemplation. As you sit here now, listening to these words drift through the quiet evening, countless dark matter particles are streaming through your body at velocities that would make shooting stars seem sluggish. They pass through your bones, your blood, your brain, as if you were made of the thinnest morning mist, yet their collective presence shapes the very galaxy that cradles our small blue world. This ghostly passage happens without fanfare, without sensation, without leaving the slightest trace of their journey through the landscape of your being. It's as if the universe has populated itself with cosmic spirits that inhabit the same space we do, but experience reality through entirely different rules. They feel no electromagnetic forces, no chemical bonds, no physical resistance to their motion, drifting through our material world like thoughts passing through a dreaming mind. The mathematics that describe this invisible realm are surprisingly elegant, filled with symmetries and relationships that seem almost too beautiful to be accidental. Some physicists speak of dark matter's behavior with the same reverence that poets reserve for particularly moving verses, as if the equations themselves contain a kind of cosmic poetry written in the language of mass and motion, gravity, and time. One of the most intriguing aspects of dark matter research is how it has revealed the universe to be far more democratic than we once imagined. Every galaxy, from the smallest dwarf to the most massive elliptical, sits embedded in its own dark matter halo, like a jewel in an invisible crown. These halos extend far beyond the visible edges of galaxies, creating a kind of cosmic personal space that influences how galaxies interact with their neighbors across the vast emptiness of intergalactic space. The relationship between visible matter and dark matter within these halos follows patterns that are both predictable and mysterious. Computer simulations show that dark matter organizes itself into remarkably consistent structures with dense central regions surrounded by more diffuse outer zones, like cosmic onions with layers upon layers of invisible substance. Yet the details of how ordinary matter settles into these dark matter scaffolds remain one of the most active areas of astronomical research. Recent observations have revealed that this relationship between dark and ordinary matter is more complex than simple gravitational attraction might suggest. Some galaxies seem to have far more dark matter than expected, while others appear to have much less, as if the invisible substance follows rules we haven't yet discovered. These anomalies have sparked debates about whether our understanding of dark matter is incomplete or whether the galaxies themselves might be telling us something profound about the nature of cosmic evolution. The search for answers has led astronomers to study galaxies at ever greater distances, peering so far into space that they observe light that began its journey when the universe was barely a tenth of its current age. These ancient galaxies reveal dark matter in its youth, showing how the invisible scaffolding of the cosmos has evolved over billions of years of cosmic time. Like archaeologists studying layers of sediment, cosmologists read the history of dark matter in the distribution of distant starlight. What they've discovered is a universe in constant, subtle motion where dark matter flows like invisible tides between galaxy clusters, carrying ordinary matter along in its gravitational wake. These cosmic currents operate on timescales so vast that entire civilizations could rise and fall in the time it takes for a single eddy to complete its circulation. Yet their influence shapes everything from the formation of the first stars to the eventual fate of the last black holes. The implications ripple through every scale of existence, from the quantum foam that bubbles at the smallest possible distances to the largest structures visible in the cosmic web. Dark matter connects these extremes in ways that challenge our intuitive understanding of how the universe operates. It suggests that reality is far more layered, far more interconnected than our everyday experience would lead us to believe. Some of the most profound insights have come from studying what happens when galaxies collide. Those slow motion cosmic crashes that unfold over hundreds of millions of years. During these encounters, The dark matter halos of the merging galaxies pass through each other almost unaffected, while the ordinary matter crashes together in spectacular displays of stellar formation and destruction. It's like watching two ghost ships sail through each other while their visible cargo spills and mingles in the space between. These collisions provide some of the clearest evidence that dark matter really is something distinct from ordinary matter, not just a misunderstanding of how gravity works on cosmic scales. The separation between visible and invisible matter during galactic mergers creates natural experiments that test our theories under conditions impossible to reproduce in any earthly laboratory. The study of these cosmic collisions has also revealed dark matter to be remarkably well behaved, following the predictions of computer simulations with surprising accuracy. This predictability has allowed scientists to use dark matter as a kind of cosmic ruler, measuring distances and masses across the universe with precision that would have seemed impossible just a few decades ago. Yet, for all its predictable behavior on large scales, dark matter continues to surprise us in the details. High resolution simulations predict that dark matter halos should contain numerous small substructures, like Russian dolls nested within Russian dolls, yet observations struggle to find all the predicted satellite galaxies and dark matter clumps. This mismatch between theory and observation has sparked intense debate about whether dark matter has properties we haven't yet discovered, or whether the simulations are missing some crucial piece of physics. The discrepancy has led some researchers to propose that dark matter might not be completely collisionless after all. Perhaps dark matter particles can interact with each other through forces so weak they barely register on cosmic scales but become important in the dense cores of dark matter halos. These self interacting dark matter models predict slightly different structures than purely collisionless particles, potentially resolving some of the tensions between theory and observation. Other scientists have suggested that the solution might lie in the complex interplay between dark matter and ordinary matter during galaxy formation. Perhaps the process of star formation creates feedback effects that redistribute dark matter in ways not captured by current simulations. The explosion of massive stars, the outflow of gas driven by stellar winds, the gravitational influence of growing black holes, all these phenomena might sculpt dark matter distributions in subtle but important ways. The search for these subtle effects has pushed observational astronomy to remarkable extremes of precision. Modern telescopes can measure the positions and motions of individual stars in nearby galaxies, tracking how they respond to the gravitational influence of their invisible dark matter halos. These stellar motions create three-dimensional maps of dark matter distribution with resolution that would have been unimaginable when Fritz Zwicky first noticed his fast-moving galaxies. The maps reveal dark matter to be surprisingly smooth on small scales, lacking the complex substructure that simulations predict. This smoothness has profound implications for what dark matter might be, ruling out some theoretical candidates while pointing toward others that interact more weakly with themselves and with ordinary matter. Each new observation refines our understanding, gradually narrowing the range of possibilities for this most elusive of cosmic constituents. But perhaps the most remarkable aspect of modern dark matter research is how it has transformed our relationship with the invisible. We have learned to see through gravitational eyes, to perceive mass and motion through their effects on light and matter rather than through direct contact. This represents a fundamental expansion of human sensory capability, allowing us to explore realms of existence that lie forever beyond the reach of our evolved perceptions. The techniques developed for dark matter research have found unexpected applications in other fields, from medical imaging to financial modeling. The mathematical methods used to reconstruct dark matter distributions from gravitational lensing observations have improved our ability to see inside the human body without invasive procedures. The statistical techniques developed to analyze cosmic structure have enhanced our understanding of complex systems ranging from climate patterns to economic networks. This cross pollination of ideas reminds us that the search for dark matter, while focused on cosmic mysteries, ultimately teaches us new ways of thinking about information, inference, and the relationship between observation and reality. We learn not just about the universe's hidden mass, but about the hidden depths of mathematical reasoning itself, discovering new ways to extract knowledge from incomplete data and uncertain measurements. The philosophical implications continue to unfold as our understanding deepens. If consciousness is somehow related to the complex organization of matter and energy, what might it mean to live in a universe where most of the matter exists in forms completely inaccessible to conscious experience? Are we like islands of awareness in an ocean of unconscious substance? Or might dark matter support its own forms of organization and complexity that we cannot yet imagine? These questions venture into speculative territory, but they remind us that dark matter research touches on some of the deepest mysteries of existence. The relationship between mind and matter, between the observer and the observed, between what can be known and what must remain forever hidden. All these fundamental questions take on new dimensions when we recognize that most of reality consists of substances we can never directly encounter. As we drift toward the conclusion of our gentle exploration, we find ourselves changed by the encounter with cosmic mystery. Dark matter has taught us to see with new eyes, to perceive patterns in absence, to find meaning in emptiness. It has shown us that the universe is far stranger and more wonderful than we ever imagined, filled with forms of existence that challenge every assumption about what it means to be real. The story of dark matter is ultimately a story about the limits and possibilities of human knowledge, about our capacity to understand truths that lie beyond direct experience, about the courage required to follow evidence wherever it leads, even when it challenges our most basic assumptions about reality. In learning to perceive the invisible, we discover not just new facts about the cosmos, but new ways of being human in a universe far more mysterious than we ever dared to dream. And so, as countless dark matter particles continue their silent passage through your being, carrying with them the gravitational memory of cosmic evolution, remember that you are part of something vast and strange and beautiful, a conscious arrangement of the universe's rarest ingredient, contemplating the nature of its most abundant component. In that contemplation, in that quiet wonder at the mystery that surrounds us, we touch something profound about what it means to be aware in a cosmos that reveals its deepest secrets, only to those patient enough to listen for whispers in the dark. The gentle dance between what we know and what remains hidden reaches its most poignant expression in the cosmic future that dark matter is quietly orchestrating. Picture the universe billions of years from now, when the last stars have flickered out and galaxies drift like ghost ships through an ever expanding ocean of space. Even then, dark matter will persist, maintaining its invisible vigil long after every source of light has been extinguished. This far future cosmos will be a realm of profound solitude, where dark matter halos mark the locations of long dead galaxies like cosmic tombstones in an infinite cemetery. The particles that make up these halos will continue their patient orbits, following gravitational pathways carved out when the universe was young and full of starlight. They are the ultimate survivors, outlasting not just individual stars, but entire stellar populations, carrying within their motions the gravitational memory of epochs when space blazed with the light of a trillion suns. But even this distant future holds surprises that dark matter research has revealed. As the universe expands and cools, as temperatures drop toward absolute zero, and space becomes emptier than any vacuum we can create on Earth, dark matter might finally reveal secrets it has kept hidden for cosmic ages. Some theories suggest that under these extreme conditions, dark matter particles might begin to interact in ways currently impossible, perhaps even decaying into lighter particles that could be detected by hypothetical civilizations of the far future. The timescales involved stretch human imagination to its limits. We speak casually of billions of years, but the processes that govern dark matter evolution operate on scales that dwarf even geological time. The dark matter particles streaming through your body right now might have been following their current trajectories since before the Earth formed, and they may continue unchanged long after our Sun has expanded into a red giant and consumed the inner planets. This temporal permanence gives dark matter a kind of cosmic authority, like an ancient presence that has witnessed the birth and death of countless worlds. If particles could remember, dark matter would carry within itself the history of cosmic evolution from the first moments after the Big Bang to the heat death of the universe. It has seen the formation of the first stars, the assembly of the first galaxies, the emergence of heavy elements that would eventually coalesce into planets and perhaps into life itself. The relationship between dark matter and the possibility of life extends beyond mere gravitational scaffolding. Some researchers have begun to explore whether the distribution of dark matter might influence the development of habitable conditions in unexpected ways. The density of dark matter in our local region of the galaxy, the way it flows through the solar system, even its potential interaction with Earth's magnetic field, all these factors might play subtle roles in creating the stable conditions necessary for complex chemistry and biological evolution. Consider that as our solar system orbits the galactic center, it moves through regions of varying dark matter density, like a ship sailing through invisible currents. These variations occur on timescales of millions of years, roughly corresponding to ice ages and periods of climate change on Earth. While any connection remains highly speculative, it illustrates how dark matter connects the smallest scales of terrestrial existence to the largest scales of cosmic structure. Oh, the search for these connections has led to some of the most ambitious experiments ever conceived. Deep underground, in laboratories carved from solid rock, scientists maintain vigils that span decades, waiting for the whisper of a single dark matter particle as it passes through their detectors. These underground cathedrals represent temples to human curiosity, places where patience and precision converge in pursuit of truths that lie just beyond the edge of perception. The detectors themselves are marvels of engineering and artistry, instruments so sensitive they must be isolated from every conceivable source of interference. They sit in chambers carved from rock that formed before complex life appeared on Earth, shielded by miles of stone from the cosmic ray showers that constantly bombard our planet. The materials used in their construction are purified to levels that approach the theoretical limits of chemical separation, creating environments of almost supernatural cleanliness and quiet. Yet, despite this extraordinary effort, despite investments of time and resources that span generations of scientists, dark matter maintains its essential mystery. Each negative result, each failed detection, each theoretical prediction that doesn't quite match observation adds another layer to our understanding while keeping the ultimate truth tantalizingly beyond reach. It's like trying to catch whispers in a windstorm, always hearing something just at the edge of comprehension, but never quite able to make out the words. This persistent elusiveness has led some researchers to embrace what they call the cosmic humility that dark matter teaches. Perhaps the universe is under no obligation to reveal its secrets easily to creatures like us, evolved to perceive only the narrowest slice of reality. Maybe the greatest discoveries require not just better instruments, but entirely new ways of thinking about what it means to know something, to understand something, to interact with aspects of reality that operate according to rules completely outside our sensory experience. The philosophical implications ripple outward like waves from a stone dropped in still water. If most of the universe consists of substances we cannot directly perceive, what does that say about the nature of knowledge itself? How many other hidden layers might reality contain? Are there forms of existence so foreign to our experience that we lack even the concepts necessary to imagine them? These questions have begun to influence fields far beyond physics and astronomy. Philosophers grapple with what dark matter means for theories of consciousness and perception. Artists find inspiration in the idea of invisible realms that shape everything we see. Writers explore what it might mean to live in a universe where most of reality remains forever hidden from direct experience. The cultural impact of dark matter extends into our everyday language and metaphor. We speak of hidden influences, invisible forces, the weight of things we cannot see. In some sense, dark matter has become a scientific validation of intuitions poets and mystics have expressed for centuries, the recognition that reality contains depths and dimensions that lie beyond ordinary perception. But unlike mystical intuitions, the reality of dark matter rests on evidence that can be shared, tested, and refined through careful observation and mathematical analysis. It represents a new kind of empirical mysticism, if such a term makes sense, where wonder and precision converge in pursuit of truths that challenge our most basic assumptions about the nature of existence. The technological legacy of dark matter research continues to unfold in unexpected directions. The ultra sensitive detectors developed for particle physics have found applications in medical imaging, allowing doctors to see inside the human body with unprecedented clarity. The computational techniques used to simulate dark matter evolution have improved weather forecasting and climate modeling. The statistical methods developed to analyze cosmic structure have enhanced our understanding of complex networks in fields ranging from biology to economics. This cross pollination reminds us that the search for cosmic truth often yields practical benefits in ways that cannot be predicted or planned. The scientists who first proposed dark matter could never have imagined that their theoretical investigations would eventually contribute to medical diagnosis or environmental monitoring. Yet the tools and techniques developed in pursuit of the invisible have found their way into technologies that touch our daily lives in countless subtle ways. The international collaboration required for dark matter research has also created new models for how humanity might approach its greatest challenges. The experiments searching for dark matter particles bring together scientists from dozens of countries, sharing resources and expertise across cultural and political boundaries. The data they collect belongs not to any single nation, but to the entire human species, representing our collective effort to understand our place in the cosmos. This collaborative spirit extends to the theoretical work as well, where ideas flow freely between research groups scattered across the globe. An insight developed in one laboratory might spark a breakthrough in another on the opposite side of the planet. The search for dark matter has created a kind of invisible network of human curiosity that spans continents and cultures, united by shared questions about the nature of reality. As we approach the gentle conclusion of our exploration, we find ourselves transformed by the encounter with cosmic mystery. Dark matter has taught us to see beyond the visible, to perceive patterns in absence, to find meaning in the spaces between certainties. It has revealed the universe to be far stranger and more wonderful than we ever imagined, filled with layers of existence that challenge every assumption about what it means to be real. The whispers of science that brought us to this understanding continue to echo through the darkness between stars, carrying questions that may outlive our species and mysteries that may persist long after the last black hole has evaporated into the quantum foam. In those whispers, we hear something timeless about the relationship between consciousness and cosmos, between the observer and the observed, between the profound loneliness of awareness and the even more profound recognition that we are part of something vast and strange and beautiful. Dark matter surrounds us like a gentle presence, invisible yet influential, unknowable yet somehow within our understanding. It reminds us that mystery is not the enemy of knowledge, but its most faithful companion, that the greatest discoveries often begin with the simple recognition that things are not quite what they seem. In learning to perceive the invisible, we discover not just new facts about the universe, but new ways of being human in a reality far more layered and luminous than we ever dared to dream. And so, as you drift towards sleep tonight, remember that you carry within yourself both the rarest and most common substances in the universe, that your consciousness represents an arrangement of cosmic matter complex enough to contemplate its own existence and wonder at the invisible architecture that holds everything together. In that wondering, in that gentle amazement at the mystery that embraces us, we touch something profound about what it means to be aware in a cosmos that reveals its deepest truths only to those patient enough to listen for whispers in the dark. The story of dark matter weaves itself through the fabric of human curiosity in ways that mirror the invisible threads it creates throughout the cosmos. Picture the moment when a young graduate student first encounters the rotation curves of spiral galaxies, those elegant graphs that should show stars slowing down as they move farther from galactic centers, but instead reveal something impossible: velocities that remain stubbornly flat, defying every expectation based on visible matter alone. This moment of recognition, repeated in laboratories and observatories around the world, represents a kind of scientific awakening. It's the instant when the comfortable certainties of Newtonian physics give way to something far more mysterious and profound. The universe reveals itself to be not just stranger than we imagine, but stranger than we can imagine, populated by substances that follow rules so foreign to our experience they might as well be magic. Yet there's something deeply human about our response to this cosmic puzzle. Rather than retreating into comfortable ignorance, we've chosen to pursue the invisible with a passion that borders on obsession. We've built detectors of extraordinary sensitivity, developed mathematical frameworks of breathtaking complexity, and devoted entire careers to understanding something we may never be able to touch. It's as if we've fallen in love with a ghost, pursuing a relationship with something that can influence our lives, but never fully reveal itself. The mathematics that describe dark matter's behavior possess an austere beauty that speaks to something fundamental about the architecture of reality. These equations don't merely calculate, they sing quiet songs about how mass and space and time interact in the cosmic darkness. Physicists often speak of these mathematical relationships with the same reverence that musicians reserve for particularly moving compositions, as if the formulas themselves contain melodies that echo through the structure of existence. Consider how dark matter has transformed our understanding of what it means to map the universe. Traditional cartographers work with landscapes they can walk upon, oceans they can sail across, mountains they can climb. But cosmic cartographers must chart territories that exist only in the realm of gravitational influence, creating atlases of the unseeable through careful inference and mathematical deduction. These maps of invisible matter represent one of humanity's most remarkable intellectual achievements, revealing hidden geographies that shape everything we observe, yet remain forever beyond direct experience. The relationship between dark matter and time takes on particularly poetic dimensions when we consider how slowly cosmic structures evolve. A dark matter halo might maintain its basic shape for billions of years, longer than it takes for entire mountain ranges to rise and fall on Earth. These invisible structures possess a kind of temporal permanence that dwarfs human civilization, creating cosmic landmarks that persist across geological ages. They are the universe's most patient architects, building scaffolding for galaxies with the unhurried persistence of geological forces. But dark matter's influence extends beyond mere structural support into the realm of cosmic aesthetics. The way galaxies distribute themselves throughout space, the elegant spiral arms that sweep through stellar disks, the graceful dance of galaxy clusters as they slowly orbit common centers of mass. All these patterns reflect the underlying architecture of invisible matter. Dark matter is not just the universe's hidden foundation, it's also its unseen artist, shaping cosmic beauty according to principles we're only beginning to understand. The search for dark matter has created its own culture within the scientific community, complete with shared rituals, common languages, and collective dreams. Researchers speak of detector backgrounds and cross sections with the familiarity of old friends discussing the weather. They gather at conferences to share their latest non detections with the enthusiasm of explorers comparing maps of uncharted territories. There's something beautifully paradoxical about a community united by their collective failure to find what they're looking for, bound together by the shared pursuit of something that continues to elude their grasp. The underground laboratories where dark matter detection takes place have evolved into spaces of almost monastic dedication. Scientists descend into these carved chambers like modern anchorites, seeking revelation through patient observation and careful measurement. The detectors themselves sit in silence that approaches the absolute, waiting with electronic patience for events that may never come. There's something profoundly moving about this vigil, this willingness to spend years listening for whispers that might never be spoken. The technology developed for dark matter research has reached levels of sensitivity that border on the miraculous. Modern detectors can register energy deposits equivalent to a single photon of visible light, can distinguish between different types of particle interactions with precision that would have seemed impossible just decades ago. These instruments represent humanity at its most ingenious, pushing the boundaries of what's technically possible in pursuit of answers to questions that challenge our most fundamental assumptions about reality. Yet, for all this technological sophistication, there remains something deeply humble about dark matter research. Each experiment begins with the acknowledgement that we don't know what we're looking for, that we're searching for something whose properties we can only guess at. It's science practiced at the edge of ignorance, where the most honest answer to most questions is still, we don't know. This intellectual humility has become one of the field's most attractive characteristics, a willingness to embrace uncertainty while continuing to search for understanding. The computer simulations used to model dark matter evolution create virtual universes of stunning complexity and beauty. These digital cosmos contain billions of particles following gravitational laws across eons of simulated time, generating structures that mirror the real universe in remarkable detail. Watching these simulations unfold is like witnessing the birth of galaxies in fast forward, seeing how invisible matter flows and clusters and creates the scaffolding upon which cosmic architecture is built. There's something almost divine about this ability to create universes, even virtual ones, and watch them evolve according to fundamental physical laws. The implications of dark matter research ripple outward into unexpected areas of human knowledge. The statistical techniques developed to analyze cosmic structure have found applications in fields ranging from genetics to economics. The ultra-pure materials created for particle detectors have advanced materials science in ways that benefit technologies from solar panels to computer chips. The collaborative methods developed for international experiments have influenced how we approach other global challenges, from climate change to pandemic response. But perhaps the most profound legacy of dark matter research lies in how it has expanded our conception of what it means to know something. We've learned to trust indirect evidence, to build understanding from absence rather than presence, to find meaning in the spaces between certainties. This represents a fundamental evolution in human cognition, a new way of relating to reality that acknowledges the limits of direct perception while refusing to let those limits constrain our curiosity. The cultural impact of dark matter extends far beyond the scientific community. Artists find inspiration in the idea of invisible realms that shape everything we see. Writers explore narratives where the most important characters remain forever off stage. Philosophers grapple with what it means to live in a universe where most of reality lies beyond direct experience. Dark matter has entered our collective imagination as a symbol of mystery itself, representing all the hidden influences that shape our lives in ways we can barely comprehend. The educational challenges posed by dark matter have forced science teachers to develop new ways of explaining concepts that challenge common sense. How do you teach students about something that can't be seen, touched, or directly measured? The answer has led to innovative pedagogical approaches that emphasize inference, pattern recognition, and the power of mathematical reasoning. Students learn to think like cosmic detectives, following chains of evidence that lead to conclusions about invisible realms. The international nature of dark matter research has created communities of scientists who share not just data and techniques, but dreams and disappointments. Researchers from different continents collaborate on experiments that span decades, building relationships that transcend national boundaries and cultural differences. There's something hopeful about this aspect of the search, the way it brings together people from around the world in pursuit of answers to questions that belong to all humanity. The failure to directly detect dark matter particles after decades of searching has led to some unexpected philosophical insights. Science, we've learned, doesn't always progress through dramatic discoveries and sudden breakthroughs. Sometimes, the most important advances come through patient accumulation of negative results, through the gradual elimination of possibilities that brings us closer to truth, even when we can't yet see what that truth might be. Dark matter research has taught us to find value in non discovery, to celebrate the knowledge that comes from learning what something isn't, even when we can't yet determine what it is. The future of dark matter research promises even more sensitive detectors, more sophisticated simulations, more creative theoretical approaches to understanding the invisible. New generations of underground laboratories are being planned that will push sensitivity to levels that approach fundamental quantum limits. Space based observatories will map dark matter's distribution with unprecedented precision. Particle accelerators of extraordinary power may finally create dark matter particles under controlled conditions. Yet there remains the tantalizing possibility that dark matter will continue to elude direct detection, that it will remain forever at the edge of our ability to interact with it directly. This possibility doesn't diminish the importance of the search, it enhances it. The pursuit of dark matter has already transformed our understanding of the cosmos and our place within it. It has taught us to see beyond the visible, to think beyond the tangible, to embrace mystery as a companion rather than an enemy. As we drift toward the conclusion of our gentle exploration, we find ourselves changed by the encounter with cosmic mystery. Dark matter has revealed the universe to be far more layered and complex than we ever imagined, filled with realms of existence that challenge every assumption about the nature of reality. It has shown us that the most important truths often lie hidden in plain sight, that the greatest discoveries sometimes come from paying attention to small discrepancies that don't quite fit our expectations. The whispers of science that have guided us through this journey continue to echo in the spaces between galaxies, carrying questions that may outlive our civilization and mysteries that may persist long after the last star has burned out. In those whispers, we hear something profound about the relationship between consciousness and cosmos, between the known and the unknowable, between the humble recognition of our limitations and the extraordinary reach of human curiosity. Dark matter surrounds us like a gentle, invisible presence, shaping everything we see while remaining forever beyond our direct grasp. It reminds us that wonder is not incompatible with knowledge, but essential to it, that the greatest questions often arise at the boundaries of what we think we understand. In learning to perceive the invisible architecture of the universe, we discover not just new facts about cosmic structure, but new ways of being human in a reality far more mysterious and beautiful than we ever dared to imagine. And so we arrive at a place where mathematics meets meditation, where the search for invisible matter becomes a search for invisible truths about the nature of existence itself. The equations that govern dark matter's behavior don't merely describe physical processes, they whisper something profound about the relationship between what can be known and what must remain forever mysterious, between the precision of scientific measurement and the poetry of cosmic wonder. In the quiet hours before dawn, when radio telescopes sweep across distant galaxies and underground detectors maintain their patient vigil, we find ourselves part of a species that has learned to love what it cannot touch. We have developed a kind of cosmic empathy, an ability to sense the presence of substances that exist in realms completely parallel to our own. It's as if we've learned to hear music played in frequencies beyond our natural range, to see colors that exist outside the spectrum of visible light. The story of dark matter research reveals something beautiful about human persistence in the face of mystery. Generation after generation of scientists have devoted their careers to understanding something that refuses to reveal itself directly, building upon each other's work with the patience of cathedral builders who know they may never see the completed spire. There's something deeply moving about this collective dedication, this willingness to pursue truth, even when that truth remains perpetually just beyond reach. Consider how dark matter has changed our relationship with absence itself. In our daily lives, we tend to think of empty space as truly empty, of darkness as the mere absence of light. But dark matter teaches us that absence can be more substantial than presence, that the spaces between things might be filled with influences more powerful than the things themselves. It's as if we've discovered that silence contains more music than sound, that shadows cast more light than the sun. The children growing up today will inherit a universe stranger than any generation before them could have imagined. They will learn from the beginning that most of reality consists of substances they cannot see, cannot touch, cannot directly experience in any way. Yet this invisible realm shapes everything they do experience, from the motion of stars in the night sky to the very existence of the galaxy that contains their small blue world. These children will grow up native speakers of a cosmic language that includes mystery as a fundamental vocabulary. The implications ripple through our understanding of consciousness itself. If awareness arose from complex arrangements of ordinary matter, what might it mean that ordinary matter represents such a tiny fraction of cosmic substance? Are we like candle flames flickering briefly in a vast warehouse filled with invisible cargo? Our small light illuminating only the tiniest corner of something immeasurably larger? Or might consciousness be more fundamental than we imagine? A property that emerges wherever matter organizes itself with sufficient complexity, regardless of whether that matter happens to interact electromagnetically. The underground laboratories where scientists search for dark matter particles have become inadvertent monasteries of modern science, places where human dedication meets cosmic mystery in the deepest silence our technology can create. The researchers who maintain these vigils speak of their work with a kind of reverent patience, as if they understand that some truths reveal themselves only to those willing to wait with infinite care and attention. These detection experiments represent humanity at its most hopeful and humble simultaneously. Hopeful because we believe the universe will eventually yield its secrets to patient inquiry. Humble because we acknowledge that those secrets might be written in languages we're only beginning to learn to read. Each day that passes without detection is both a disappointment and a kind of prayer, a recognition that reality operates according to its own timeline rather than our eager expectations. The mathematical frameworks developed to understand dark matter possess an austere elegance that speaks to something fundamental about the deep structure of reality. These equations don't merely calculate, they reveal relationships between mass and space and time that seem almost too beautiful to be accidental. Physicists working with these formulas often describe a sense of discovering rather than inventing, as if the mathematics already existed in some Platonic realm and human minds simply learned to perceive its eternal patterns. The computer simulations that model dark matter evolution create digital universes of breathtaking scope and subtlety. Billions of invisible particles follow gravitational laws across eons of simulated time, generating cosmic structures that mirror our own universe with remarkable fidelity. Watching these simulations unfold feels like witnessing the birth of galaxies in fast forward, seeing how invisible scaffolding grows into the architecture that supports everything we observe in the night sky. Yet, for all our technological sophistication, dark matter maintains its essential mystery with what seems almost like cosmic politeness. It reveals just enough of itself to let us know it's there, shapes just enough of cosmic structure to make its presence unmistakable, yet remains forever beyond the reach of direct interaction. It's as if the universe has constructed the perfect hiding place, invisible to all our senses, yet influential enough to determine the fate of galaxies. The search for dark matter has taught us new ways of seeing that extend far beyond astronomy and physics. We've learned to perceive patterns in absence, to find meaning in the spaces between certainties, to trust evidence that points toward truths our senses cannot directly confirm. This represents a fundamental expansion of human cognitive capacity, a new kind of sight that operates through mathematical reasoning rather than electromagnetic radiation. The cultural impact continues to unfold in unexpected directions. Artists find inspiration in the idea of invisible realms that shape everything visible. Writers explore narratives where the most important characters never appear on stage. Musicians compose pieces that attempt to capture the sound of cosmic silence, the rhythm of gravitational waves, the harmony of equations that describe invisible matter. Dark matter has entered our collective imagination as a symbol for all the hidden influences that shape our lives in ways we can barely comprehend. The international collaborations required for dark matter research have created new models of human cooperation that span continents and cultures. Scientists from dozens of countries share data and insights with a generosity that reflects the universal nature of the questions they're pursuing. The search for cosmic truth has become a genuinely global endeavor, uniting people across political and cultural boundaries in pursuit of understanding that belongs to all humanity. The educational challenges posed by teaching about dark matter have led to innovative approaches that emphasize inference, pattern recognition, and the power of mathematical reasoning. Students learn to think like cosmic detectives, following chains of evidence that lead to conclusions about realms they can never directly experience. This kind of education prepares young minds not just for careers in science, but for living thoughtfully in a reality that contains depths and dimensions far beyond immediate perception. The failure to directly detect dark matter particles after decades of searching has become its own kind of success, teaching us that science doesn't always progress through dramatic breakthroughs and sudden revelations. Sometimes, the most important advances come through patient accumulation of constraints, through gradual elimination of possibilities that brings us closer to truth, even when we can't yet see what that truth might be. We've learned to find value in non discovery, to celebrate the knowledge that comes from understanding what something isn't. The technological legacy of dark matter research continues to surprise us with unexpected applications. Ultrasensitive detectors developed for particle physics have revolutionized medical imaging. Computational techniques created for cosmological simulations have improved weather forecasting and climate modeling. Statistical methods designed to analyze cosmic structure have found uses in fields ranging from genetics to economics. The search for invisible matter has yielded visible benefits in ways that could never have been predicted or planned. But perhaps the most profound gift of dark matter research is how it has expanded our capacity for wonder. We've learned to be amazed by absence, to find beauty in mystery, to embrace questions that may never be fully answered. This represents a mature relationship with knowledge that acknowledges the limits of human understanding while refusing to let those limits constrain our curiosity about the nature of existence. The future promises even more sensitive detectors, more sophisticated theories, more creative approaches to understanding the invisible. New generations of experiments will push the boundaries of what's technically possible in pursuit of particles that may forever remain at the edge of detectability. Space based observatories will map dark matter's distribution with unprecedented precision, creating atlases of the unseeable that reveal the hidden geography of cosmic structure. Yet there remains the beautiful possibility that dark matter will continue to elude direct detection, that it will remain forever just beyond our ability to touch or capture or fully comprehend. This possibility doesn't diminish the importance of the search, it enhances it. The pursuit itself has already transformed our understanding of reality and our place within it. We've learned to see beyond the visible, to think beyond the tangible, to find meaning in mystery itself. The whispers of science that have guided us through this gentle exploration continue to echo through the cosmic dark, carrying questions that may outlive our species and mysteries that may persist long after the last black hole has evaporated into quantum foam. These whispers speak of a universe far more layered and luminous than we ever imagined, where consciousness arose from cosmic dust to contemplate the invisible architecture that holds everything together. As you prepare to drift into sleep tonight, remember that you are surrounded by mystery in its most elegant form. Dark matter streams through your dreams as silently as it flows through your waking hours, shaping the galaxy that cradles your small world while remaining forever beyond your direct perception. In that gentle presence, in that invisible embrace, we find not cause for fear, but reason for wonder, not evidence of our insignificance, but proof of our extraordinary capacity to perceive truths that lie beyond the reach of our senses. The universe has spent nearly 14 billion years weaving dark matter into its very fabric, creating a cosmos where mystery outweighs certainty, where the invisible shapes the visible, where wonder remains the most appropriate response to existence itself. And in our patient search for understanding, in our willingness to pursue truth, even into realms we may never fully comprehend, we discover something profound about what it means to be conscious in a reality far stranger and more beautiful than anything we might have dared to imagine. Sleep well, gentle listener, knowing that you are part of something vast and mysterious and infinitely patient, where dark matter continues its ancient work with the quiet persistence of cosmic time, holding galaxies together while whispering secrets. We're only beginning to learn how to hear. The gentle persistence of dark matter extends into realms we're only beginning to glimpse, where the very concepts of detection and discovery take on meanings that stretch the boundaries of human understanding. Imagine trying to study the wind by watching how it moves leaves, except the leaves themselves are invisible, and you must infer their dance from shadows cast by light you cannot see. This is the exquisite challenge that dark matter presents to our most sensitive instruments and our most creative minds. Deep beneath the surface of our world, in caverns carved from rock that remembers the birth of continents, scientists have created spaces of such profound quiet that they approach the silence between thoughts. Here, in chambers lined with materials purer than anything nature produces on its own, detectors wait with the patience of geological time for encounters that may never come. These underground sanctuaries represent humanity at its most hopeful and humble, places where we've learned to listen for whispers so faint they might be mistaken for the quantum heartbeat of empty space itself. The technology housed in these subterranean laboratories reads like poetry written in the language of precision. Crystals cooled to temperatures that would freeze the motion of molecules, noble gases so pure they make distilled water seem contaminated, sensors capable of detecting energy transfers smaller than the collision of dust motes in a sunbeam. Each component represents years of development, decades of refinement, entire careers devoted to creating windows into realms that exist parallel to our own, yet remain forever beyond direct touch. But the true marvel isn't the technology itself, it's what the technology represents. Our species' willingness to build cathedrals to uncertainty, to invest our finest minds and most precious resources in pursuit of something that may choose never to reveal itself. We've become cosmic archaeologists, studying civilizations that exist only in mathematical possibility, reading histories written in the gravitational curvature of space-time itself. The data these experiments collect tells stories and languages we're still learning to speak. Each day without detection is both absence and presence, a negative result that somehow adds to our understanding while deepening the mystery. We've learned to find meaning in emptiness, to extract knowledge from what doesn't happen, to build theories on foundations of carefully measured nothing. It's as if we've discovered that silence contains more information than sound, that the spaces between notes carry the true melody of cosmic music. The international collaborations that sustain this research have created communities of seekers who share not just data and techniques, but dreams and disappointments across continents and cultures. Researchers who may never meet in person exchange insights that span time zones and languages, united by questions that belong to no single nation but to the entire human family. There's something beautiful about this invisible network of curiosity, this web of wondering minds that mirrors the cosmic web they study, connected by threads of shared fascination rather than dark matter filaments. The mathematical frameworks that emerge from this research possess an austere elegance that speaks to something fundamental about the architecture of reality. These equations don't merely calculate, they sing quiet songs about relationships between mass and space and time that seem almost too harmonious to be accidental. Physicists working with these formulas often describe moments of recognition rather than discovery, as if the mathematics already existed in some eternal realm, and human minds simply learned to perceive its timeless patterns. Consider how dark matter research has transformed our understanding of what it means to map the universe. Traditional cartographers work with territories they can walk across, oceans they can sail upon, mountains they can climb. But cosmic cartographers must chart realms that exist only as gravitational influence, creating atlases of the unseeable through pure mathematical inference. These maps of invisible matter represent perhaps humanity's most remarkable intellectual achievement, revealing hidden geographies that shape everything we observe, yet remain forever beyond the reach of any camera or telescope. The computer simulations that model dark matter's cosmic dance create digital universes of breathtaking complexity and subtle beauty. Billions of invisible particles follow gravitational choreography across eons of simulated time, generating structures that mirror our own cosmos with remarkable fidelity. Watching these simulations unfold feels like witnessing the birth of galaxies in time-lapse photography, seeing how invisible scaffolding grows into the architecture that supports every star we've ever observed twinkling in the night sky. Yet, for all our technological sophistication, dark matter maintains its essential mystery with what seems almost like cosmic courtesy. It reveals just enough of itself to make its presence unmistakable, influences just enough of galactic structure to demand our attention, yet remains forever poised at the threshold of direct interaction. It's as if the universe has constructed the perfect philosophical puzzle, something that can be known to exist without ever being fully known, understood without ever being completely comprehended. The implications ripple through every aspect of how we think about knowledge itself. We've learned to trust indirect evidence, to build understanding from absence rather than presence, to find profound meaning in the careful measurement of what isn't there. This represents a fundamental evolution in human cognition, a new way of relating to reality that acknowledges the limits of direct perception while refusing to let those limits constrain our curiosity about the nature of existence. The children growing up today will inherit a universe stranger than any generation before them could have imagined. They'll learn from their earliest years that most of reality consists of substances they cannot see, cannot touch, cannot directly experience through any of their evolved senses. Yet this invisible realm shapes everything they do experience, from the spiral arms of the galaxy that contains their world to the very possibility of planets and stars and life itself. These young minds will grow up as native speakers of a cosmic language that includes mystery as fundamental vocabulary. The cultural impact of dark matter research extends far beyond the boundaries of science into art, literature, philosophy, and the quiet contemplations that occupy our thoughts in the small hours before dawn. Artists find inspiration in the idea of invisible realms that shape everything visible. Writers explore narratives where the most important characters never appear directly on stage. Musicians attempt to capture the rhythm of gravitational waves, the harmony of equations that describe matter we cannot see. Dark matter has entered our collective imagination as a symbol for all the hidden influences that shape our lives in ways we can barely comprehend. The search has also revealed unexpected connections between the smallest and largest scales of existence. The same quantum mechanical principles that govern the behavior of individual atoms influence how dark matter particles might interact with ordinary matter. The same gravitational forces that hold galaxy clusters together operate within the ultra-sensitive detectors buried miles beneath our feet. This unity of physics across cosmic scales suggests that understanding dark matter might unlock insights into other profound mysteries, from the nature of consciousness to the ultimate fate of everything we hold dear. But perhaps the most profound gift that dark matter research offers is how it has expanded our capacity for wonder itself. We've learned to be amazed by absence, to find beauty in mystery, to embrace questions that may never yield complete answers. This represents a mature relationship with knowledge that acknowledges the boundaries of human understanding while celebrating the extraordinary reach of human curiosity. We've discovered that some of the most important truths reveal themselves not through dramatic breakthroughs, but through patient accumulation of carefully gathered evidence, through the gradual elimination of impossibilities that brings us ever closer to understanding what remains. The underground laboratories, where this patient work continues, have become inadvertent temples to the power of sustained attention, places where human dedication meets cosmic mystery in profound silence. The researchers who maintain these vigils speak of their work with quiet reverence, understanding that some discoveries require not just sophisticated instruments, but a willingness to wait with infinite care for revelations that unfold according to their own mysterious timeline rather than our eager expectations. Each negative result, each day without detection, each theoretical prediction that doesn't quite match observation adds another layer to our understanding while keeping the ultimate truth tantalizingly beyond reach. We've learned to find value in non discovery, to celebrate the knowledge that comes from understanding what something isn't even when we cannot yet determine what it is. This patient acceptance of uncertainty has become one of the field's most attractive characteristics, a willingness to embrace mystery as a companion rather than an obstacle to knowledge. The technological legacy of this research continues to surprise us with applications that extend far beyond the original questions that motivated the work. Ultra-sensitive detection methods developed for particle physics have revolutionized medical imaging, allowing doctors to peer inside the human body with unprecedented clarity. Computational techniques created for cosmological simulations have improved weather forecasting and climate modeling. Statistical methods designed to analyze the large scale structure of the universe have found uses in fields ranging from genetics to economics, from network analysis to artificial intelligence. This cross pollination of ideas reminds us that the pursuit of fundamental knowledge, even knowledge that seems utterly impractical, often yields practical benefits in ways that cannot be predicted or planned. The scientists who first proposed the existence of dark matter could never have imagined that their theoretical investigations would eventually contribute to medical diagnosis, environmental monitoring, or any of the countless technologies that now benefit from techniques originally developed to study invisible matter. The future promises even more sensitive experiments, more sophisticated theoretical frameworks, more creative approaches to understanding the unseeable. New generations of underground detectors will push sensitivity to levels that approach fundamental quantum limits. Space based observatories will map dark matter's distribution with unprecedented precision, creating three-dimensional atlases of cosmic architecture that reveal the hidden scaffolding upon which everything visible depends. Particle accelerators of extraordinary power may finally create dark matter under controlled laboratory conditions, bringing samples of the invisible realm into spaces where we can study them with all the tools of experimental science. Yet there remains the beautiful possibility that dark matter will continue to elude direct detection, that it will maintain its position forever at the threshold of human perception. This possibility doesn't diminish the importance of the search, it enhances it. The pursuit itself has already transformed our understanding of reality and our place within it. We've learned to see beyond the visible spectrum of existence, to think beyond the tangible realm of everyday experience, to find profound meaning in mystery itself. The story of dark matter research reveals something deeply moving about human persistence in the face of the unknown. Generation after generation of scientists have devoted their careers to understanding something that refuses to reveal itself directly, building upon each other's work with the patience of cathedral builders who know they may never see the completed spire. This collective dedication spans decades and continents, creating communities of inquiry that transcend national boundaries and cultural differences in pursuit of answers to questions that belong to all humanity. The whispers of science that have guided us through this gentle exploration continue to echo through the cosmic darkness between galaxies, carrying questions that may outlive our civilization and mysteries that may persist long after the last star has exhausted its nuclear fuel. In those whispers, we hear something timeless about the relationship between consciousness and cosmos, between the observer and the observed, between the humble recognition of our limitations and the extraordinary reach of human curiosity when it encounters the truly unknown. As we drift toward the conclusion of our quiet journey through the realm of invisible matter, we find ourselves changed by the encounter with cosmic mystery on such a profound scale. Dark matter has revealed the universe to be far more layered and complex than we ever dared imagine, filled with realms of existence that challenge every assumption about the nature of reality while somehow remaining woven into the very fabric of everything we see and touch and call home. The mathematics that govern this invisible realm speak in languages that bridge the gap between human understanding and cosmic truth, equations that don't merely describe, but somehow participate in the deeper harmonies that hold galaxies together across billions of years of cosmic time. In learning to read these mathematical poems, we've discovered new ways of seeing that operate through pure reasoning rather than electromagnetic radiation, new forms of perception that allow us to map territories we can never visit and understand substances we can never directly encounter. Sleep well tonight, gentle listener, knowing that you are surrounded by mystery in its most elegant and patient form, where dark matter continues its ancient work with the quiet persistence of geological time, holding the cosmic web together while whispering secrets. We're only beginning to learn how to hear in the soft silence between heartbeats and the gentle spaces between dreams. And so we arrive at the gentle end of our cosmic journey, where questions bloom like night flowers in the darkness between certainties. We've drifted through realms of invisible matter, traced the gravitational fingerprints of substances that shape everything while touching nothing, and discovered that the universe speaks its deepest truths in whispers so soft they require the silence of entire mountains to hear. The story of dark matter is ultimately the story of human curiosity itself, our remarkable capacity to love what we cannot hold, to understand what we cannot see, to find meaning in the spaces between what we think we know. We've learned that reality contains layers upon layers of existence, most of them hidden from our direct experience, yet somehow accessible to our patient reasoning and careful observation. Think of all the dark matter particles that have passed through your body during this quiet hour we've spent together. Countless invisible travelers carrying within their motion the gravitational memory of cosmic evolution, each one a messenger from realms we can map but never visit. They connect you to the largest structures in the universe, while remaining as intangible as thoughts, as influential as dreams, as present as the air you breathe, yet infinitely more elusive. The underground laboratories where scientists maintain their vigils, will continue their patient work long after you've drifted into sleep, listening for whispers that may never come, building understanding from carefully measured absence, finding profound meaning in the gentle art of not finding what they seek. There's something beautifully human about this persistence, this willingness to spend lifetimes in pursuit of truths that may forever remain just beyond our grasp. Perhaps that's the most profound lesson dark matter teaches us about the nature of knowledge itself. Some mysteries aren't meant to be solved quickly or easily. Some truths reveal themselves only to those willing to wait with infinite patience, to listen with extraordinary care, to find wonder in questions that may outlive the questioner. In learning to perceive the invisible architecture of the cosmos, we've discovered new ways of being human in a universe far stranger and more beautiful than we ever imagined possible. The children who will grow up knowing about dark matter from their earliest years will inherit a cosmos where mystery is not the enemy of understanding, but its most faithful companion. They'll learn to see beyond the narrow spectrum of electromagnetic radiation their eyes detect, to think beyond the limited range of forces their bodies can feel, to find profound meaning in the recognition that most of reality operates according to rules completely outside their sensory experience. And in some quiet moment, perhaps while gazing up at stars whose light has traveled millions of years to reach their eyes, these future humans might pause to consider how those same stars are held in their cosmic dance by substances as invisible as hope, as influential as love, as mysterious as consciousness itself. They'll understand that they live embedded in layers of existence that extend far beyond anything their ancestors could have conceived, surrounded by forms of matter that share their space while remaining forever beyond their touch. The cosmic web of dark matter that cradles our galaxy will continue its patient work long after our sun has swelled into a red giant and consumed the inner planets, long after the last black holes have evaporated into quantum foam, long after the universe has expanded and cooled beyond the possibility of stars or planets or life as we know it. Yet, even in that far future, the gravitational memories preserved in dark matter's distribution will carry forward the story of cosmic evolution, maintaining a kind of universal archive written in the language of invisible matter. But for now, in this moment, as you prepare to let consciousness drift toward sleep, remember that you are part of something vast and gentle and infinitely patient. The dark matter streaming through your dreams connects you to every galaxy in the observable universe, links your small existence to the largest structures that have ever formed, makes you a participant in cosmic processes that began before the Earth existed and will continue long after it's gone. There's comfort in this cosmic perspective, a sense of belonging to something far larger than the brief span of human concerns. We are made of stardust, as Carl Sagan reminded us, but we exist within the embrace of something even more fundamental, the invisible substance that gave structure to the universe before the first stars were born and will maintain that structure long after the last star dies. The whispers of science that have guided us through this exploration will continue to echo in the minds of researchers around the world, carrying forward questions that connect this generation to the next in an unbroken chain of curiosity about the nature of existence. Each failed detection, each refined theory, each new insight into the behavior of invisible matter adds another thread to the tapestry of human understanding, weaving together individual moments of wonder into a collective comprehension that transcends any single lifetime. If you've found peace in this gentle journey through cosmic mystery, if these whispered stories of invisible matter have brought you comfort or curiosity, or simply a moment's respite from the concerns of daily life, then perhaps you'll carry forward a small piece of the wonder that drives scientists to spend their lives studying things they can never touch. Wonder, after all, is the most renewable resource in the universe, growing stronger rather than weaker when shared, multiplying rather than diminishing when passed from one curious mind to another. And perhaps that's the most beautiful truth of all, that in seeking to understand dark matter, we've discovered something profound about the nature of understanding itself. We've learned that knowledge isn't just about grasping facts or solving puzzles, but about developing a relationship with mystery that allows us to remain curious without demanding immediate answers, to find meaning in questions that may never be fully resolved. The universe has been remarkably patient with us, revealing its secrets slowly, gently, like a teacher who understands that some lessons take time to unfold. Dark matter didn't announce itself with fanfare or dramatic revelation. Instead, it whispered its presence through the subtle motion of distant galaxies, through the gentle bending of starlight, through patterns so delicate they required decades of careful observation to detect. It taught us to pay attention to discrepancies, to notice when things don't quite match our expectations, to find profound significance in the smallest deviations from what we thought we understood. In this quiet persistence, dark matter has become more than just a scientific puzzle. It's become a meditation on the nature of existence itself, a reminder that reality contains depths we're only beginning to explore. Every underground detector waiting in patient silence, every computer simulation modeling invisible matter across cosmic time, every graduate student puzzling over rotation curves in the small hours of the morning contributes to humanity's ongoing conversation with the unknown. The legacy of this search extends far beyond any eventual discovery of dark matter particles. We've developed new ways of seeing that will serve us well as we encounter other mysteries in the cosmos. We've learned to trust mathematics when it leads us toward uncomfortable conclusions, to embrace indirect evidence when direct observation fails us, to find beauty in theories that describe realms we may never directly experience. These are skills that will serve us well as we probe other cosmic enigmas, from the nature of consciousness to the possibility of life beyond Earth. As the night deepens around you and the day's concerns begin to fade like distant stars, remember that you are connected to this grand cosmic story in the most intimate way possible. The calcium in your bones was forged in the hearts of dying stars. The iron in your blood was scattered across space by ancient supernovas, and the carbon that forms the backbone of every molecule in your body was created in stellar furnaces billions of years ago. But more than that, your very existence depends on the invisible architecture of dark matter that gave shape to the universe, that allowed galaxies to form, that created the cosmic environment where stars could ignite and planets could coalesce, and life could eventually emerge to contemplate its own existence. Tonight, as you drift toward sleep, Dark matter will continue its ancient work with the quiet persistence that has sustained it for nearly 14 billion years. It will hold galaxies in their gravitational embrace, guide the flow of cosmic rivers between galaxy clusters, maintain the invisible scaffolding that keeps our universe from collapsing into chaos or expanding into emptiness. And in that gentle, constant presence, we find not just the foundation of cosmic structure, but a kind of cosmic patience that reminds us that some of the most important things in existence work quietly, invisibly, without need for recognition or applause. The search for dark matter has taught us that wonder is not a childish thing to be outgrown, but a mature response to a universe that refuses to reveal all its secrets at once. In embracing mystery, we don't abandon reason, but expand it, developing new forms of understanding that operate through inference and mathematics rather than direct sensation. We become explorers of invisible realms, cartographers of the unseeable, students of substances that exist in the spaces between what we can touch and what we can imagine. Sleep well, gentle listener, knowing that you are part of something vast and patient and infinitely mysterious. The universe has spent eons preparing for this moment when conscious beings could emerge from cosmic dust to contemplate the invisible threads that hold everything together. In your capacity for wonder, in your ability to find meaning in mystery, in your willingness to listen for whispers in the cosmic dark, you carry forward the most precious gift that billions of years of evolution have produced, a mind capable of loving what it cannot fully comprehend, of seeking what it may never completely find, of discovering profound beauty in the recognition that reality is far stranger and more wonderful than we ever dared to dream. The whispers of science will continue long after these words fade into silence, carrying questions from one generation to the next, building understanding grain by grain, like the slow accumulation of cosmic dust that eventually forms new worlds. And in that patient work, in that gentle persistence in the face of mystery, we find perhaps the most human thing of all, the courage to keep wondering, keep seeking, keep listening for the soft voice of truth speaking to us from the darkness between the stars.